Okay, we're going to look at a proof here. We're given that BC is equal to EC and AC is equal to DC. Now, they are already marked in this picture, but again, if you're doing a proof, make sure you mark things that are given. So notice we have one tick mark, BC and CE, and then AC and DC have two tick marks. They're already shown to be equal. So let's start out with our two columns. Okay, number one, BC is equal to EC, and AC is equal to DC. And that's our given. Okay. Step number two. Now, we're trying to prove these two triangles congruent. So think about our situations we've talked about now in the last two lessons. We have two sides already. There's no way we can prove the third side, but if you think about this, we have some vertical angles here. We have this angle right here and this angle right here, which are vertical from what we've talked about in class. So we can say that angle BCA is equal to angle ECD, and the reason there would be that vertical angles are equal, or you could say the vertical angle theorem. Now, can we say the two triangles are congruent? Yes, we can. What situation do we have? We have side, angle, sides, or the angle between two congruent sides. So we can then say that triangle ABC is congruent to triangle DEC, and that would be by side, angle, side congruency. And the last example for this section, in the following diagram, Midtown is exactly halfway between uptown and downtown. What is the distance between downtown and the Lower East Side? How do you know? Write a few sentences to convince your reader is correct. So let's take a look at this. Midtown is exactly halfway between uptown and downtown. So if we know that, okay, here's the side that goes from uptown to downtown, and this is halfway right here, Midtown. That means this side must be 2.1 also, so we know these two sides are halfway there, okay, or are equal because Midtown is halfway between. Okay, so now let's look at, we also have some vertical angles here. We've got, just like we did in the last proof, we got this angle and this angle from intersecting lines are vertical, so we would know they are equal. So we've got equal sides, and we've got equal angles, and we are also given that this is a right angle and this is a right angle. So I have angles equal there as well. So if you think about this, this is an angle, side, angle situation. So these triangles are congruent, or we can state that they are congruent by ASA, angle, side, angle. Therefore, now the question asks, what is the distance between downtown and the Lower East Side? So I'm trying to find this length right here. Well, that has to be congruent. Once we get the triangles congruent, that has to be equal to this length right here. That side corresponds with that side. So downtown to Lower East Side is 1.5 kilometers, and the reason would be by CP, CTC, corresponding parts of congruent triangles are congruent. And many times when you're trying to prove things like that, you're going to get the triangles congruent first, and then specify a corresponding angle or corresponding sides are congruent.